All right.
Welcome again, Dr. Juan Gonzalez.
Okay.
From Ecuador, Dr. Juan will share with us valuable information about stackable surgical guide design using Blender for.
Okay, finally. Okay, sorry for that. Some technology inconvenience today, but we are ready to start. All right, so for those who don't know me, who don't hear about me, I'm Juan Gonzalez from Ecuador. I'm an orthodontist. Um, I'm professor at Universidad Católica de Cuenca, and I also have a private practice where we have all specialties. So I've been working as a tutor in Blender for Dental for a little longer than 2 years now. And I'm passionate about digital dentistry. Actually, I have worked during my residency in a few publications about digital dentistry, and we found how technology can be a replacement, very accurate, very precise, of what we are used to when using plaster models and when using conventional procedures or workflows. Currently, digital models provide us a way to be more efficient, right? Basically, all technology tries to bring more precision and more efficiency. Currently, all the studies have proved that digital models are equal and as precise as plaster models, but as I said before, with the convenience and efficiency that digital data brings to the table. So anyway, to understand how we can work with digital models, we need to understand what's the digital workflow. And all digital workflows works in the same way. We have 3 steps. First is how to take records or the digital records, then the design phase or CAD phase, and then we have a manufacturing phase or CAM phase. So there is a bunch of ways where we can capture this data. Basically, we need to convert all the information coming from our patient into data, into numbers. So a computer can interpret, understand what we are looking at. Then we need a software to design around those records and to create any sort of appliance or prosthesis or whatever we need. And then we have to convert this into a physical object. So then the computer-aided manufacturing appliances or equipment will let us to convert this data back into physical objects. Anyway, I think that the more important phase in this workflow is the design phase, because as you saw before, it was the center, the meat of this workflow. Currently, we have a lot of softwares to design and to work with digital data, but sometimes those softwares can be quite expensive or quite complicated. So I divide the screen into 2 different options where I think we can be. On the left side, those softwares which are simpler to use, but a lot more expensive. And on the right side, those software that can be less expensive or even free, but usually it demands more understanding of the procedures, more understanding of how the 3D world works, and let's say it has a little stepper learning curve, right? So actually, I've been working the last 2 or 3 years with just 2 softwares, which are these 2. I use these softwares for basically everything I need to design in my office, from surgical guides to splines to temporaries, etc. Everything can be done only with these two softwares, which are 3D Slicer and Blender for Dental. And actually, today we are going to talk a little about both, because this combination, this as I like to say, this perfect option of softwares will let us to design almost anything we can imagine. So this is the way I work right now, especially since we have two softwares. I like to have two screens, and also I try to make all my diagnosis and treatment plan procedures digital. So I moved from the paper, and since I'm an orthodontist, we like to measure angles and lines and stuff. I moved from that, from rulers and paperwork, to only digital workflow. So what's Blender? For starters, we have to define what's the software we want to use and why we are using it. Well, actually, Blender is a software created to design animation and 3D models for animation purposes. So as you can see in the screen, Blender can be used to work this sort of videos, or CGI videos, or a lot more. But actually, Blender is so powerful that can also be used to design anything, basically. So it has so powerful tools that can be used in different manners, like 3D printing or any kind of simulation. And because this is open software, which means that can be modified, can be basically distributed and modified in different ways, we are in a position where we can take this software that is meant to use for animation and transform it a little bit to be correct for dental purposes or to dental design. So this is the guy who started this project, Tom Rosendahl, who decided to make some good software for 3D that will be free and available for everyone. So today, I think a lot that what we do, we owe to this guy. But after this project started, but because I have to tell this, because one of the probably most common questions I receive is, what happens when Blender start or stop being available, or is going to be some time where the software will be won't be available anymore, or there won't be updates in the future. Well, as you can see, Tom Rosendahl started the project in 1989, as I said, to give the population some powerful tool to do 3D design. And under this license, the GNU license, which is, as I said, an open source license. And this project started to grow big. And in 2002, it found the Blender Foundation, which get collaboration of a lot of people, and the software made a big change. It was very, very complex to use in the past, but with newer and newer updates, it's becoming easier and easier, right? And today, I think this software provides us what I call creative freedom. So we can design actually whatever we like, beyond dental stuff, right? And where Blender for Dental come in place? Well, after a few years, the Blender project was growing so big that these guys, Michael and Wolfgang Teinecker, found in this project a great way to design dental stuff. But it was very complex. It requires so many steps. So they start transforming the software, as I said, to make it simpler and to make it easier for the user, more user-friendly, and provide or create this tool, which is called Blender for Dental, in a very low cost. So Blender for Dental is an add-on for the Blender software. So this means that we will have to install in our computers first the Blender software, and then inside it, we're gonna put Blender for Dental. Right now, Blender for Dental is available for Windows and Mac, and we can use it for 3 computers. Once you purchase this add-on, you can use it for 3 computers simultaneously, and you will have lifetime access. All right. It will include future updates, which is great because tools are getting better and better with time. This is a modular software, which means it's created with different parts, different little menus or little modules that you can use for different purposes. So for example, in this case, we have 6 of the main modules: model designer, articulator, ICP, etc. Each module is meant to be used for a specific work. So in this case, for example, we have the model designer. Model designer is the main tool, is the only one that is mandatory to work with everything else in Blender for Dental. And it allows us to modify meshes. Finally, when you take a scan, when you create a digital model, you get a mesh. But the mesh can have little problems, can be little imperfections in there. So Blender Model Designer will allow us to clean those imperfections, to fill little holes, to clean the mesh, as I said, and then have a model perfect, ready for 3D printing, right? So after you have the model ready for 3D printing, you have other tools that you will need to use, especially when we are designing guides, surgical guides. So main thing is to have a good quality model. So here I am showing a few other tools this model designer module have. As you can see, it trains the model perfectly, and then you create bases. You can correct some imperfections and basically clean the mesh, right? So it looks quite good. And then you can even cut the mesh in little parts, in little pieces, so you can print it, right? So you will have, at the end of the day, at the end of this module, models perfect for 3D printing. Even you can create these dies. So for laboratory procedures, it's great. All right. And also you can use a small articulator, which is included in this module. This, as I said, is a mandatory module because it has all the information necessary to work with all other modules in Blender for Dental. And it has a retail price, I think, of $79 for three computers. So I think he's a impressive software for a very low price. All right, so you have different options to have those small articulators to print, to 3D print. And of course, you can put labels in here and have your models with a patient name, etc. All right. We have other module, which is the logo designer. The logo designer is meant to put your company logo, your lab logo, or your clinic logo in the models to have them look a little nicer. We have a trade designer, which is quite nice when you are doing implant works, implant procedures, because you can create in like a minute or so custom tray, which can include space for the implant, and it is very, very simple to print, and it works really nice. Then we have the main module for this presentation, which is the guide designer. Guide designer is a very big module, has been around for a little longer than, almost as long as Blender for Dental started. They So the importance of having a guide module. As you can see, you can design those tubes, which are actually the guidance for the drill. And also you can design some smaller guides for putting pins, like fixation pins. All right, this is actually a very powerful module, and it can be used for a lot of purposes, not only for implant guides, but for example, in my case, for mini screw guides, because as I said, Blender for Dental has this freedom of design. So I can work in different manners. This was a test we were doing. And here is an implant case. This is an O1 from a friend of mine. And at the end, you can print the guide in a proper material. That's very important. You have to use biocompatible material and then use it in the mouth. Particularly in orthodontics, this implant place, this specific TAT or mini screw position is very interesting. It's called the infrazygomatic crest TAT because it avoids the roots of the tooth. But what most people don't say is that you have a big risk to perforate the sinus. So when you have this big risk, actually literature mentioned that this insertion site is quite often to create this problem, to perforate the sinus. So if you have this risk, it's a lot better to do it with virtual planning. So in my case, that's why I'm using these sort of guides always when I'm using infrazygomatic crest TATs. And we can use, of course, for palatal TATs, which are very, very common in our clinic. As you can see, the guide works quite easily. And here's a small video. Of course, this is a lot simpler than an implant, but at the end of the day, the procedure is basically the same. You can see those tubes I was showing before guide perfectly the tip of this screwdriver or handle in my motor. These are self-perforating mini screws, so they get in there quite easily. And as you can see, in about a minute or so, I will have my implant in place, and exactly in the exact same side where I have planned this. All right, there it is. I have finished the implant placement. Now I just have to remove everything. You can see it there. This patient got 4 mini screws in the palate. It looks like that. And we use it for expansion. So we then put another appliance in there. This is another case of a friend of mine where we have to make some adjustments to have those two implants very close together. And as you can see, we also have here these metal rings. And why is this important? Because in my case, it's not that hard to have the small tip around the plastic, which is the printed resin. But when we want to be very precise and avoid any maybe remaining of the resin contacting the patient, we can use these small cylinders. In the surgical guide workflow, we have the option to design spaces in the plastic to insert those small metal cylinders, and then those will work as a guidance for the drill and the implant during the surgical procedure, right? So here, as you can see, we design both upper and lower implant guides, and those are the drills. the sleeves, I mean, the metallic rings or metallic sleeves. And now, what about these stackable guides? This is a very popular procedure right now. It's getting very common, and Blender for Dental have a full workflow to design this sort of guides. Actually, you can have as many layers, as many different pieces in the lower part as you like. And you can design the upper, or I mean, you can convert the upper into a plastic piece or a metallic piece. So the joint between both the upper and lower parts is this. I don't know if you can see my mouse. I hope so. Are these small like cones, and these have a small step in there. So when you insert those guides, when you insert that part, it will click in place, and you will have a very secure guide that you can interchange with different elements, right? That's the main concept of this stackable guide. So in this case, I have the guide, and then I have the temporary. So they will be exactly in the same place and will be perfectly fitting on those upper guide, right? Same for the stats, same thing. You can design with the same guide designer other kind of guides, like endodontic guides for open cavity, also for, as you can see here, for gingivectomy. Everything can be designed just with this module. However, in the full workflow, you still need more stuff, more modules. Particularly on this case, we need the alignment module, because we need to have a perfect match between what is in the mouth and what we have in our digital case, right? So the ICP alignment tool use algorithm called iterative close exploit, actually. And what it is basically a way to compare two meshes and align them perfectly together. So this can be used to align two models, for example, if you have two pieces, or it can be used to align the bite. But most importantly, in our case, it can be used to align the scan bodies. So when we have the patient, the scan of the mouth, we then align the digital scan body with the scan body. And we have the perfect position for these analogs to design maybe later the prosthesis, right, or the crown. Actually, the same module will be used to align the upper scan with the CBCT, because as you saw before, we use the cone beam tomography to have the information of the patient, and we need to align the upper scan with that cone beam, and we will have now a virtual patient where we can plan the correct position of the implant. So this module is necessary to make that alignment, and then we can start designing the guide. All right. There's a lot of other uses, as you can see. We can use to align the face. Here, as I was telling you, I'm showing you how to align the models to the scan, to the cone beam scan. But also you can align two models. This is something I like a lot in orthodontics, very interesting. When you have two different time models, you can use some structures that are stable in the palatal structures, and that will give you a way to understand what's happening on your treatment and if you're getting to your goals. So here I can superimpose in this palatal rugae and then see what's the change in my dentition. Of course, I can see it visually and I can measure it and see if I have, like in this case, a correct vertical control or not. and if I have accomplished the amount of movement I need, etc. Right? So here, this article is saying that basically that is a very precise way to analyze or to understand the changes, but without using radiation, which is awesome. So this tool, this module is very interesting. I like it a lot, and I use it quite often. And now they have also a gum designer module, which is very nice to design this virtual gum. Then you can later print, and by using analog procedures, create the crown. It's not mandatory, of course. You can just design the crown directly in the 3D software, but it's an option. It's good to have different options. Other module that is very common now is the articulator. They have a very nice articulator where you can use, well, you can use a lot of ways to reorient the face or the models, the upper and lower scans. I originally tried to use, actually, this is the Facebook. This is called the COIS Facebook, or Dentofacial Analyzer Facebook of COIS. And if I'm digital, taking this to the digital world, I can align my models. But what Blender for Dental is bringing to the table is the option to use pictures. So you can have standardized pictures to align those models. And as you can see here, it will give you a very nice result without any Facebook, right? Finally, we have the Spline Designer, which is a very nice module to design a lot of stuff. The original name was Spline Designer, but it can be used to design a lot more than splines. Now it's called Spline and Layers. And this is the articulator, sorry. Here is the Spline Designer. And you can design, of course, splines, but you can do also small works like maybe partial denture structures or anything that can be adapted to the dentition. So I have created a lot of different splines, but also orthopedic treatments and all sorts of appliances. Like in this case, I'm working with these palatal tabs, and I need some sort of appliance to hold my elastics. So this is called the spider screw, or the spider appliance, which is not available in my country. So what I did is just I use this Spline Designer. I design my own spider appliance. I print it, and I cast it, and then we get this. Of course, the laboratory did all this, that we get the exact same appliance as I designed. Here is the castable resin model, and then I have here my appliance in the mouth. All right, so this works perfectly. Same thing with this, the modified C-palatal appliance, which same concept. I designed my own C-palatal modified appliance, and I print those in castable resin, and we get a final metal version of it, and it works quite well. Also, for the sleep apnea, we designed this sort of appliance, and everything is done with the same Spline and layer designer. So here, these have also screws, so you can move the mandible forward or not. And here we have one of the main modules also, which is the wax-up module. When we are doing implant work, we can use this module to define the correct position of the temporary and to plan or implant work around it, right? So of course, this can be due to diagnostic, can be used to make diagnostic wax-ups, and a lot more, because this, as other modules, this software talks between them. Okay, so modules work together, and WhatsApp will work with the crown designer module and etc. So they work between them. Actually, here it is, the crown and bridges module, which allow us to design all sorts of permanent prostheses like crowns and bridges and inlays, onlays, implant crowns, etc. So here you are seeing a little fast example of how this model work. You can see that we have some blue teeth in there and also some green stuff in there, which is basically a way to know if we have enough space for the material, and we can design using this information to understand if we are having a correct design. All right. Finally, this is one of the newest modules, which is called the I-bar. And also, this is a very popular procedure right now, the designing of bars, of these metallic bars for hybrid dentures. And here you can see how this model works. They are calling this reverse engineering. Basically, usually you design the bar and then you design the prosthesis over it. But in this case, we start with the actual hybrid design and we create the bar inside it. So that's why this is reverse engineering. You can see it has so many steps, but at the end of the day, it will take maybe like 10 minutes or so to do it. And there you can see how the bar is looking. You have a lot of tools to make it the proper dimension, the angle, the roundness, etc. You have so many options in this model. It's very simple to use, and you will get something like this, which is the hybrid with the space inside and then the bar. So you can then mill the bar, mill the prosthesis, and install it in the mouth. All right, there it is. Now you can have some retentions in there, a lot of stuff. Beautiful, very, very nice module. And as I said, it works with all others. Another interesting thing they put in the table is this vertex split concept, which is designed to do these Geller models, these dies, so you can put and remove the dies. It has these bases. You can buy separately the base and then print the model with these canals in there, so you can snap the pieces into place. It takes like 5 minutes to do so, and you print it and you have removable dies very quickly. This is something that is not ready yet, but hopefully next year we will have orthodontic modules for aligners and also IDB, indirect bonding. So basically there is a lot of tools you can use, and in this workflow we were talking today, which is surgical guides, you need to understand a lot of modules. So that's why we are looking to explain the step-by-step of these procedures using different modules. Basically, we need the blockout, model designer, surgical guide or guide module, and the alignment. We need 4 to create those stackable guides or any sort of guide. So we're gonna go step by step in a future time that we can see back. All right, so actually this is the way I see Blender for Dental. I think we have two sides of this table. We have the open source side where the price is very, very low, but the difficulty is very high. And the other side, if we pay a lot more, we can have softwares that are a lot easier, but of course, more expensive. So I think Blender for Dental maybe relies in here. Actually, if we take into account that after you take a course, it will be a lot easier to understand. We can get it here. Right, so basically we have a learning curve as in any other software, but we need to short this learning curve as much as possible. So just to end this, here are my website, my information. So if you want to contact me, let me know.
Thank you very much, Dr. Joan, and wish to see you in Dubai in 10 and 11 of May 2023 for in-depth course step by step. Thank you very much. Have a nice.
See you guys. Thank you.
Bye-bye.
Bye.